Okay, so on this one, you're going to find the orthocenter. The orthocenter is the point of concurrency of the altitudes of the triangle. So just quickly to graph this triangle, M is 3, 5. N is 2 over -3 down. And O is 9 over 4 up. And so we need to find a couple altitudes. You only need 2 of them, even though there are 3 altitudes in the triangle. And the way that you find an altitude is by finding a line that goes through a vertex and is perpendicular. And so what you need to find the slope of the line that you need to be perpendicular to. And so, for example, if we want the altitude through point M, then we need to find the slope of NO. And in this case, that's going to equal 4 minus a -3, y1 minus y2. And then it's going to be over 9 minus 2. And that does turn out to be 7 over 7, which is 1. But we need the perpendicular slope. Well, that's the negative reciprocal. 1 doesn't have the 1 is the reciprocal of itself. But we do need to take the negative. So the slope of the altitude is going to have be -1. So we can say using the only point that we can use, we don't use the midpoint for this because this is not a perpendicular bisector. Instead, we use the vertex that we want to go through. And so in this case, that vertex is 3, 5. And so 5 goes in for y, -1 for x, -1 for slope, 3 for x plus b. So add 3 from both sides and you get b equals 8. So the equation of the line is y equals -x plus 8. And that seems reasonable when you look at it. And so then we can do the other one. It doesn't matter which one we do. So we'll just do the one that goes through O. And so that means we need the slope of AN. And so the slope of AN is going to be 5 minus a -3 over 3 minus 2. And so that turns out to give you a slope of 8. And so the slope that we then need is the negative reciprocal of 8, which is -1/8. And so we're going to say, and again, the point that you use is a point that's not on there. So since we're finding the slope there of MN, it should have been an M, my bad. Then the point we're going to use is the third point, O, because we need the line to be perpendicular to MN, but go through point O. And so it's going to be 4 for y, and then -1/8 times 9 plus b. -9 times 8 is -1 1/8. So add 1 1/8 to both sides. And we get y equals -1/8 x plus, well, 5 1/8, which is, because you're just adding 1/8 to both sides to the 4. And so 5 1/8, which is going to be the same as 41 over 8. And so these are our 2 equations. We want to find out where they intersect each other. And so we can just set them equal to each other because we're solving the system. And so we're just plugging in the -x plus 8 in for y here. So it's going to be -1/8 x plus 41 over 8. Add the 1/8 x, it gives you a -7/8 x. Subtract the 8. And so 8 is the same as -64 over 8. And so you're going to do 41 plus 8 minus 64 over 8, which equals -23 over 8. And so that gives us -7/8 x equals -23 over 8. So we multiply both sides by the reciprocal of this. So we're going to multiply by -8/7. The -8's cancel. We end up with a positive 23 over 7. And so we know 23 over 7 is the x value for the orthocenter. But if we substitute 23 over 7 in here, we get 33 over 7 for y. So the x coordinate's 23 over 7. The y coordinate's 33 over 7, the two lines that we had were y equals negative x plus 8 and y equals negative 1/8 x plus 41 over 8.